We will start with 18 FT 305, and it talks about basics of fiber, yarn and fabric manufacturing, and we are at unit 4, that is the modern spinning systems. Now in this we will see in the lesson 3 that different types of spinning system which we have already discussed, that is the rotor spun, friction spun, twistless spinning, etc. So we will try to compare this in this modern spinning systems, and also we will see the yarn quality parameters. Let us see, starting with this difference between the ring and rotor spun yarn. Now as ring spun yarn is made of twisting and thinning the cotton strands to make a very fine, strong, soft rope of cotton fibers. Now, most yarns made from the staple fibers are the ring spun yarn. Now the difference between the ring spun yarn and the rotor spun yarn is shown clearly here. So the structural differences are there between ring and rotor spun yarn. Now let us see some other differences of this rotor and this ring spun yarn. Rotor spun yarns appear to be no different from the ring spun yarn on the surface. Important differences is in the internal structure of the yarns. Now differences in internal structure are reflected in different performance characteristics when you use such yarn in the fabric or the garment. Now comparison of ring spun and rotor spun yarns. Now if we see, this is the structure of ring spun and rotor spun yarn, and there are varieties of parameters are available between the ring spun and the rotor spun yarn. Okay. So production rate, you can see the ring spun yarn is high, but rotor spun yarn is more than this ring spun yarn. Tenacity point of view, ring spun yarn is stronger, very high tenacity, but in case of rotor spun yarn it is average. Okay. Linear density, there is a difference in the text as you can see. Twist also, the lower twist is there in the ring spun yarn, but in the rotor spun yarn higher twist. Extensibility, average in ring spun yarn, higher in the rotor spun yarn. Similarly, if you go into the abrasion resistance part, so there abrasion resistance is lower in case of rotor spun yarn, but in case of rotor spun it is higher. So rotor spun yarn abrasion resistance is higher than the ring spun yarn. Now strength variation, if you try to compare, high strength variation in the ring spun but is lower in rotor spun yarn. Yarn faults also, if you see, it is quite high in case of ring spun yarn, but it is reduced in case of rotor spun yarn. End breaks also is high in case of ring spun, and rotor spun it is little bit of less than ring spun yarn. Similarly, the fly formation is high in case of ring spun yarn, rotor spun yarn it is low. So in this fashion, hairiness, nappiness also you can see that it is higher in case of ring spun and lower in case of rotor spun yarn. Handle also, if you see, it is a softer handle in case of ring spun yarn, but rotor spun yarn it is little bit of harder. Similarly, different other properties like wrapper fibers, very important here. It is some sort of wrapper fibers are present or not present, that you can see. In the ring spun yarn there is no wrapper fiber concept, but in the rotor spun yarn this is there. So in this fashion, lot of differences are there between the ring spun and the rotor spun yarn, structurally also and different characters also. So it differs. Now end uses, if we see in the ring spun yarn, As can be seen in the diagram, the ring spun yarn, the production of ring spun yarn, if you try to compare, then it produces very coarse to extremely fine yarn with a very large range of twist density. So because of that, ring spun yarns are widely used for making shirts, trousers, nightwear, blouses, overall, suits, skirts, seating, cartooning and other industrial textiles. Now end uses of the rotor spun yarn, if you try to see, you can see the rotor spun yarn, the processing sequence and also the rotor spun yarn in the image. Now spinning good quality yarns of 18 to 200 ticks from cotton polyester blends, viscose rayon and acrylic fibers. And from microfibers, it is now quite possible to spin yarns down to 10 ticks. So these are the important end uses of rotor spun yarns. Now dress materials can be produced from this rotor spun yarn, denim and jeans, sheeting, leisure wear, then industrial wear, interlining, towels, furnishing and warp knits. So those are the end uses of rotor spun yarns. Now process flowchart, if you try to compare of ring spinning, as we can see, there are two types of flowchart available. One is the carded yarn, so blow room, carding, breaker draw frame, finisher draw frame, simplex, ring frame and autoconer. Now in case of combed yarn, blow room, carding machine, breaker draw frame, lap formations, then comber is an additional process, and then comes the finisher draw frame, simplex, ring frame and autoconer. So two different flowcharts for the carded yarn processing and combed yarn processing in case of ring spinning. Now if you see the rotor spun yarn, very simple process. The blow room, carding machines, then draw frame, and there is no use of any simplex, you can see, roving is not there. So directly those draw frame material are fed into the rotor spinning machine. So that's why production also is very high in case of rotor spun yarn, and rotor spinning process also is very simple process compared to the ring spun yarn. Now let us see the process flowchart of air jet spinning. As can be seen here, the process flowchart, it starts from the blow room, then carding machines, draw frame 1, draw frame 2, then draw frame 3 and finally the air jet spinning machine. So this is the flowchart of air jet spinning. Now let us compare principles of ring spinning, rotor spinning and air jet spinning systems. We can see in the figure the ring spinning system, then the rotor spun system is shown in this photograph, and finally the air jet spinning. So you can see the machineries, the mechanism of operations, all these things are different when we talk about the principles of ring, rotor and air jet spinning system. Now if you try to compare more, we can see a table where different process parameters of 20 NE that is compared between the carded ring, rotor and air jet spun yarns. So fiber type is taken 100% cotton in all cases, staple length 28 millimeter in case of ring, 21 in case of rotor and 28 in case of air jet spinning. Then drawn fiber hank 70 grains per yard. So in this fashion all these things have been selected, roving also selected, TM twist multiplier 4.7 in all cases, and yarn count 20 is any in all cases. So these type of things were compared between different parameters of these yarns. And then the yarn imperfections were studied. As we can see that U percentage is little less in the air jet spun yarn and more in case of ring spun yarn. Rotor lies in between air and the ring spun yarn. So CV percentage, coefficient of variation, also you can see it is more in case of ring spun yarn in comparison to air jet spun yarn kind of thing. And then you can see the thin, thick place and the naps. Okay, so these variations are there in this. In case of the naps, you can see the more number of naps in certain areas of the ring spun yarn, but less in case of air jet and rotor spun yarn. Similarly, the yarn hairiness, when you try to compare, you can see the hairiness index kind of thing also. It is somewhat more hairiness in the ring spun yarn rather than the rotor or the air jet spun yarn. So in that fashion, if you also see the count strength product or the strength of the yarn, if you try to compare, you can see that ring spun yarn is more strength is there compared to rotor spun or the air jet spun yarn. So this is the basic comparison between the ring, rotor and air jet spun. Now in a diagrammatic representations, if you try to see the mass variations, okay, mass variation in terms of U percentage, okay, unevenness percentage and CV, coefficient of variation, you can see that where it stands. U percentage of ring spun yarn, unevenness percentage is higher than this rotor or the air jet spun yarn. Similarly, the coefficient of variations, if you try to compare, you can see the ring spun yarn is having more variations than the rotor and the air jet. So this is in a diagrammatic representation of the mass variations to compare the ring, rotor and the air jet spinning. Now you can see in this diagram also that how this thick place, thin place and the naps per kilometer has been expressed here. So ring spun yarn, you can see, is more in case of rotor or the air jet spun yarn. So that is the this one disadvantage of ring spun yarn. Thick places are more, okay. Similarly, the naps are more in this case. Thin ends are almost equal to them. So more in case of yarn like ring spun yarn in comparison to air jet and rotor. So similarly, the thick places are also more in case of ring spun yarn rather than the rotor or the air jet. So this is the comparison between the thick place, thin place and naps in this ring, rotor and air jet spinning. Now in this system, the hairiness, if one tries to compare, then we can see the ring spun yarn is more hairy than the rotor spun yarn or the air jet spun yarn. So hairiness, if you compare, it is less in air jet spinning in comparison to both ring and rotor lies in between ring and air. So this is the comparative assessment of the hairiness of the fibers. Now let us see the count strength product of or the strength of the material. So obviously from this diagram we can see that ring spun yarn is having more CSP, count strength product, and less count strength product is there in the rotor, and rotor and air jet is almost similar kind of thing. So we can conclude here that the ring spun yarn is having the more strength in comparison to the rotor spinning and the air jet spinning. Now comparison between the ring, rotor and air jet spinning, if you see that different other properties are also compared here. So how these mass variations, imperfections and hairiness and strength lies. So mass variation of rotor spun yarn is about 8% less and air jet yarn is about 12% less than the ring spun yarn. So this is the conclusion we can draw from these figures when we compare. So different other properties can also be compared in the rotor spun yarn. So different yarn is having their different characteristics. So that is shown in this comparison. Now if you see that hairiness of rotor spun yarn, so it is about 17 or 12% less and air jet is about 20% less than the ring spun yarn. It again varies depending upon the nature of the yarn, where it has been collected, nature of the fibers from where it has been taken. And then the strength properties of rotor spun yarn, about 24% less and air jet is about 20% less than the ring spun yarn. So these are the different characteristics of like a mass variation of the yarn, then imperfections in the yarn, hairiness of the yarn. So those kind of things are calculated here, and finally the strength. And we come to the conclusion that the ring spun yarn is much better in terms of strength properties. Now if you try to compare the structural things, then we can see the images of different spun yarns are shown here: ring, rotor and air jet and open end friction spinning. Now let us come to the summary part of it. So we have compared the new spinning system, and mainly we have taken the air jet, ring and rotor, okay, and compared in the open end system of spinning. So thank you very much. Thank you.